Hi everyone, it's noon where I am, so we're going to go ahead and get started. Welcome to the second webinar of the 2017 WIFTIN webinar series. Today we'll be talking about invasive species acting as passengers and drivers in changes in ecosystems. So if you're not familiar with the Wisconsin First Detector Network, if this is the first time you've joined us, I'll let you know that we're a statewide citizen science network focused on invasive species detection and reporting, and also general invasive species education. So we provide training through webinars and in-person workshops, and a variety of resources for people that are interested in learning more about invasive species. We also support a number of volunteer opportunities for monitoring, managing invasive species, and doing some invasive species outreach in your communities. So in later webinars, we'll be talking more about some of those opportunities. Today you'll be hearing from me. I'm Ann Pierce, and I coordinate the Wisconsin First Detector Network. I work with Mark Renz, who is our extension weed specialist. He's on the road today, so he might be calling in, but he won't be joining us from webinar headquarters today. And so let's get started talking about invasive species as passengers or drivers. In today's session, I'm going to give a brief introduction to the idea of passengers and drivers with invasive species, and then we're going to hear from two guest speakers, and I'll introduce each of them when it's their turn to speak. So as a reminder, invasive species cause a lot of negative impacts in ecosystems. Some indirect impacts could be loss of biodiversity, changing food webs, altering other ecosystem properties, and sometimes these invasive species are directly competing with native species for food and water resources or other resources like light if you're a plant. They can also directly predate on native species. And the reason I bring that up is because today we're going to be talking a lot about the impacts that invasive species have and trying to figure out how they cause those impacts in ecosystems. If you're not familiar with the idea of invasive species as passengers or drivers, it's one model that's used to describe how they function in an ecosystem and how they cause the impacts that we see in the ecosystems that they invade. So it helps us answer questions like, how are particular invasive species successful in a given ecosystem? And then if we can learn how they're functioning, we can start trying to answer questions about how to best manage those invasive species. Some people view passengers and drivers as a spectrum, so they would be on opposite ends of the spectrum. You might find that a helpful way to view it. So some invasive species might act very clearly like drivers in an ecosystem. Others might act very clearly like passengers. But as with any spectrum, it's complicated. Most species might have characteristics of either passengers or drivers, or might be somewhere in the middle. So let's start with drivers, kind of explaining how drivers function. If you have an uninvaded site represented by this green square, drivers coming in as this red arrow are able to directly invade the site by competing directly with native species. So they might actively suppress the growth of native species or outcompete them for other resources. So over time, you end up having an ecosystem that's overwhelmingly populated by invasive species, and these drivers are really pushing against the native species. The native species aren't able to compete back very strongly. Passengers act a little bit differently. So again, consider an uninvaded ecosystem. In this case, some sort of ecosystem disturbance has to occur before the invasive species are able to invade. So this could be something like a disturbance caused by a large natural hazard event. So if there's a big storm that causes a lot of trees to blow down and you all of a sudden have a lot of light in an area that was formerly shaded by trees, or you have a lot of exposed soil, that could be the type of disturbance that native species might not be able to cope with, but it will allow invasive species who can cope with those conditions to then invade. So over time in a system like this, the system has dealt with the initial disturbance or pressure from some force. It could be a natural disturbance, it could be human disturbance. We often talk about our urban development creating a lot of negative impacts in ecosystems. So it could be something caused by that then allows the invasive species acting like passengers to kind of ride along in that disturbance and be able to establish themselves. And just like with the drivers in these situations, there's a lot of pressure being exerted on the native species by both the disturbance and the invasive species acting as passengers, and those native species have a tough time surviving. So people generally describe the impacts of drivers and passengers as drivers directly decreasing biodiversity because they're directly competing with native species. In plant communities, drivers are also considered to alter successional trajectories. So if you're familiar with plant succession, the drivers can directly impact that. Passengers, on the other hand, are more just a symptom of the disturbances. So they don't directly decrease biodiversity. In systems where invasive species acting like passengers are growing, you might see loss of biodiversity, but that's attributed more to the disturbance rather than directly to the invasive species. So once we begin to understand how these invasive species act, we can then think about our management. So on this slide, there's two identical plots that you'll see on the left side for drivers, on the right side for passengers. On the y-axis, we're looking at the similarity of the site to an uninvaded site. And on the x-axis, along the bottom, we're looking at the abundance of invasive species. So the green square represents a non-invaded site. You'll see it has no or very low invasive species abundance, whereas the red triangle represents a site dominated by invasive species. So if we consider a couple different management actions, some options would be to either just remove the invasive species to try to return the invaded site to a non-invaded state, or we could try to restore the ecosystem properties or processes that have been disturbed. In the case of drivers on the left side, it's expected that if you remove those invasive species, you'll be able to return the site to its non-invaded state, because the invasive species acting like drivers, are driving all of those changes. Once they're removed, the site will be able to recover. On the other hand, with passengers, it's thought that if you remove the invasive species, what you're basically going to be able to do is to decrease the abundance of that particular species, but you're not going to get to the point where that site is at the state it was before, because it's still dealing with the underlying disturbances that allowed the invasive species to get there in the first place. So in this case, the management would be more focused on restoring the ecosystem properties or processes that created the initial disturbance. So going back to our example of urban development, that often creates a lot of issues with stormwater infiltration into natural areas. So natural areas end up dealing with a much heavier load of stormwater than they previously did. So if that inundation with stormwater allows the invasive species acting as a passenger to invade the site, then managing the stormwater would be a more successful way to restore the site than just removing the invasive species. The passenger versus driver model can be a little bit confusing, and as we said before, you can consider these as two different ends of the spectrum, where drivers are at one end, passengers are at the other end, but most species aren't going to neatly fall into either category. And if you start to consider the fact that most of our ecosystems have multiple invasive species, you can begin to see how quickly this can get really complicated in terms of trying to figure out how the invasive species are acting and how we can manage them.